Okay, let us start with this chapter. This is the third chapter in the chemistry part of class 9th syllabus. Okay, so atoms and molecules. Ancient Indian and Greek philosophers, they have always wondered about the unknown and unseen form of matter. The idea of divisibility of matter was considered long back in India around 500 BC. So see, this divisibility, the idea of divisibility, it was talked about in India around in 500 BC. Okay, so an Indian philosopher, his name is Maharishi Kannad. Maharshi Kannad, what he postulated that if we go on dividing matter, matter in Hindi is called padarth. Okay, if we go on dividing matter, that is padarth, we shall get smaller and smaller particles. Ultimately, a stage will come when we shall come across the smallest particles beyond which further division will not be possible. So Maharshi Kannad, what he said, that if we keep on dividing any matter you already know, they exist in three states like solid, liquid and gas, right? So if we keep on anything which is existing in the form of solid, liquid and gas, keep on dividing, a stage will come when it cannot be further divided. Okay, so he named these particles as Parmanu. So this word Parmanu was given by whom? By Maharshi Kannad. Okay, there is another Indian philosopher, his name is Pakuda Katyam. He elaborated this doctrine and said these particles normally exist in a combined form which gives us various forms of matter. What he said, that these Parmanus, these indivisible particles, they stay in the combined form. They are staying means they are together, they bind with one another, and that is what is responsible for giving us different forms of matter. That was told by Pakuda Katyam, another philosopher. Okay, so around the same era, ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be further divided. Okay, a stage will come when particles will not be divided further. So Democritus called these indivisible particles atoms. It means indivisible. So this word atom, what it means? It means indivisible, and this word was given by whom? Democritus. Democritus was the person who gave this word, and that is what we are learning these days. Okay. So let us switch to the next page. Okay, fine. So all this was, okay, read further. All this was based on philosophical consideration and not on experimental work to validate these ideas could be done till 18th century. Okay, so it was all philosophical. These were all what people thought, they told and they tried to explain, but there was not much of experimental proof till 18th century. Okay, by the end of 18th century, scientists recognized the difference between the elements and compounds. So it is by 18th century, in 18th century, scientists started recognizing what is the difference between the elements and compounds, and naturally became interested in finding out how and why elements combine and what happens when they combine, right? Then there was a person called Antony L. Lavoisier. Okay, Antony L. Lavoisier. He laid down the foundation of chemical sciences by establishing two important laws of chemical combination. Okay, so he was the one who was the person, Antony Lavoisier. He explained about law of chemical combination, how different elements or compounds, they are reacting, how they combine together. So a law was given by him, and that is what we are going to study next, law of chemical combination. Okay, fine. Now the following two laws of chemical combinations were established after much experimentation by Lavoisier and Joseph Proust. Two people were there who were involved in the experimentation work. One was Lavoisier, another one was Joseph Proust. Lavoisier and Joseph Proust, they gave the law of chemical combination. Now try to understand this through this activity which is given. Is there is there a change in mass when a chemical change or a chemical reaction take place? So this was a question. Now just think logically, will there be any change in the mass when a chemical change or chemical reaction is taking place, or is it going to remain same? Let us say when two things are reacting, it will give something which is different from what has reacted. So here the question is, will there be any change in the mass of what is being formed, or is going to remain the same? Okay, so let us see this activity. Take one of the following set as X and Y of chemical. Take two sets, like suppose X is one of the chemical, Y is another chemical. Let's say copper sulfate sodium carbonate. Okay, so barium chloride and sodium sulfate. Okay, lead nitrate and sodium chloride. Let's say lead nitrate is this much and sodium chloride we are taking this much amount. Okay, barium chloride is there and sodium sulfate, and this is the quantity which is being taken. Now prepare separately a 5% solution of any one of the pair of substance listed under X and Y in 10 ml of water. So keeping the quantity of water same, 10 ml. Okay, you can put 5%. You have to prepare a 5% solution of this. Okay, by taking this much gram of barium chloride, or you can take 1.53 gram of sodium chloride, or you can choose any one of these chemicals. Now take a little amount of the solutions of Y in a conical flask. Now as you take this solution Y, like this part is the X. Okay, your barium chloride is X and sodium sulfate is Y. Okay, consider one of this as X. Suppose you are taking lead nitrate, let this be X and this be Y. Okay, so when you are taking this, take a little amount of solution Y in a conical flask and some solution of X in an ignition tube. Okay, so you can see this is a picture of conical flask which is shown. You have kept the solution Y. You have to take solution Y. Okay, and in another test tube you are keeping your solution X. Fine. In the test tube, in the conical flask, keep one solution. In the another flask you keep another one. Now see, hang the ignition tube in the flask carefully. See that the solution do not get mixed. Put a cork on the flask. Okay, now weigh the flask with its content carefully. Now tilt and swirl the flask so that the solution X and Y are getting mixed. So when you tilt the flask, what will happen? Slowly from the test tube, the solution which is present here X will come into the solution Y. Now you can wait again and see what happens in the reaction flask. Now this conical flask is called as the reaction flask. So when you tilt this solution X into Y, what reaction is taking place and what change will happen, that you have to observe. Okay, so let's see what happens next. Why should we put a cork on the mouth of the flask? Does the mass of the flask and its content change? Okay, so we'll see these questions, because as we are not experimenting it right now, we'll see. Right now you just remember that there is a conical flask. Okay, this is a conical flask, and in this conical flask you have put a cork. So why you are putting a cork? So that in case after reaction some gases are being produced, so they do not escape out. So you have to keep it covered with this cork. And then in the test tube, this solution, okay, suppose this is a test tube. From the test tube, slowly you are going to put the solution into the conical flask solution so that they both react with each other. Okay, and now we'll see, according to law of conservation of mass, what is there and what actually happens when we do this experiment. So law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. After the reaction, after you have poured your X solution in the Y, what you will see, that the mass has not changed. It remains the same. What does it tell? That the mass can neither be created nor destroyed in a chemical reaction. So that is what is the law of conservation of mass. Law of conservation of mass states that that mass can neither be created nor be destroyed in a chemical reaction. Meaning hereby is that suppose this your x and y, when they are reacting with each other, okay, something, let us say xy is being formed, so mass of x plus mass of y is same as the mass of xy together. Okay, so I hope this is clear to you all. Now, law of constant proportion. Lavoisier. Lavoisier, along with other scientists, noted that many compounds were composed of two or more elements, and each such compound had the same elements in the same proportion, irrespective of where the compound came from or who prepared it. Okay. So, what he said, what he noted, that many compounds were composed of two or more elements. That if suppose a compound is there, compounds are made of elements. They are fixed with each other in a fixed proportion, right? In a definite proportion. So many compounds are composed of two or more elements, and each compound had the same element in the same proportion, irrespective of where the compound came from or who prepared it. So let's say with an example which is explained here, let's say there is water. Okay, so if this water is made of hydrogen, hydrogen is one of the element, oxygen is another element, and if you see hydrogen, how many elements are there? Two are there, right? Here you can see the number 2. And oxygen, how many elements? Nothing is written, means it is 1. So let water come from anywhere. If it is a water, it will have two elements, means two atoms of hydrogen and one atom of oxygen. And hydrogen and oxygen, what are they? They are the elements. Okay, this is what is explained here in this. Let me, okay. Now, in a compound such as water, okay, the ratio of mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water be. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Okay, so similarly in case of ammonia, what is how we write ammonia? That is NH3. Okay, so nitrogen and hydrogen are always present in the ratio of 14:3 by mass. See, there is one atom of nitrogen. What is the ratio? 1:2. What is the, how many hydrogen atoms are there? 3. Okay, so always we will see that nitrogen, if it is 1, like the mass of atomic mass of nitrogen is 14, so how many, what will be the mass of hydrogen? It is 3. So this mass ratio will be always 14:3. 14 is the atomic mass of nitrogen and 3 is the atomic mass of hydrogen. Okay, so I hope this thing is clear. So by mass it is being compared, that mass remains the same, okay, when they are combined. Okay, and there is a fixed proportion, whatever method or source from which it is obtained. Okay, this led to law of constant proportion. Right, what we saw here, the law of conservation of mass. Law of conservation of mass states that mass can neither be created nor destroyed. Means if two things are reacting with each other, okay, their combined mass is also going to remain the same. Another thing is the law of constant proportion. Means if suppose this x is 2, two atoms of x is combining with one atom of y, so it will be always constant. Here what will be formed? X2 plus y is how much? Y is 1. You can, I can write it like this. Okay, okay, so suppose two hydrogen atom and one oxygen, so it will be always H2O which will be formed. Okay, so one is about conservation of mass, another thing you have to remember is about the constant proportion. They are going to combine with each other, the constant proportion. Okay, fine. So let us see, this led to law of constant proportion, which this one, constant proportion, which is also known as the law of definite proportion. So law of constant proportion or definite proportion is one and the same. This law was stated by Proust as in a chemical substance the elements are always present in a definite proportion by mass. Okay, in a chemical substance the elements are always present in a definite proportion by mass. In a chemical substance, here chemical substance means any compound or combination of element. What we will see, the elements are always present in a fixed proportion or definite proportion. Okay. Now the next problem faced by scientists was to give appropriate explanation of these laws. British chemist John Dalton provided the basic theory about the nature of matter. So John Dalton, he was a British chemist, and what he gave the basic theory. Okay, theoretically he tried to explain the nature of matter. Dalton picked up the idea of divisibility of matter. Now what helped him in giving this theory? This idea of divisibility of matter, using the idea of divisibility of matter, okay, which was given by Democritus. Okay, so he tried to explain what the nature of matter could be, which was till then just a philosophy. Okay, some not an experimental proof, it was just a philosophical idea or a thought. He took the name atoms as given by Greeks and said that the smallest particle of matter are atoms. He said that the smallest particle of which any matter is formed is the atom. His theory was based on the law of chemical combination. Okay, laws of chemical combination, that is law of definite proportion and law of conservation of mass. These two are there, right? So Dalton's atomic theory provided an explanation for the law of conservation of mass and law of definite proportion. Okay, so I hope this is clear. Now we are talking about another great scientist. Okay, his name is John Dalton. You can see his picture here. He is John Dalton. What he did, before him already the idea of divisibility of matter was there, and it was called as atoms, right? So using the law of chemical combination, that is, what are the two laws of chemical combination? Law of definite proportion and law of conservation of mass. Okay, law of conservation of mass, law of definite proportion, these two are the laws of chemical combination. Okay, they both are laws of chemical combination. So based on this he gave his theory. His theory was on atom, on the nature of atom. He said something about how the nature of the atom would be. This was explained. So John Dalton was born in a poor weaver's family in 1766 in England. Okay, and he began his career as a teacher at the age of 12. So he was just 12-year old when he started working as a teacher. Okay, trying to teach children. Okay, 7 years later he became a school principal. Okay, great. Huh? See, he was just 12 years old, and 7 years later means he will be around 19. Okay, 19. So when he was just 19-year old, he became the principal of the school. 1793, Dalton left for Manchester to teach mathematics, physics and chemistry. So he is going to Manchester. There he taught these subjects, maths, physics and chemistry, in a college. He spent most of his life there teaching and researching. In 1808, he presented his